నేను మాత్రం మా ఇద్దరు పిల్లల్ని క్వాలిటీ ఎడ్యుకేషన్ అందించే ఉల్లంపర్రు మాంటిసోరీ స్కూల్లో మాత్రమే చదివిస్తాను. ఇలా అన్నీ ఉన్న చోట మన పిల్లల్ని చదివిస్తేనే వాళ్ళకి మంచి భవిష్యత్తు ఉంటుంది.
నాకు అన్ని నెంబర్ 1 కావాలి. అందుకే నా పెద్ద మనవరాల్ని అన్ని వసతులతో క్వాలిటీ ఎడ్యుకేషన్ అందిస్తున్న స్కూల్లోనే జాయిన్ చేశాను.
ఏ స్కూల్ సార్ అది?
ఉల్లంపర్రు మాంటిసరీ స్కూల్. క్వాలిటీ ఎడ్యుకేషన్ లో నెంబర్ 1, కల్చరల్ యాక్టివిటీస్ లో నెంబర్ 1, స్పోర్ట్స్ లో నెంబర్ 1, క్యాంపస్ లో నెంబర్ 1.
అది
మీ పిల్లల బంగారు భవిష్యత్తుకు మాది బాధ్యత.
Good morning, children. In the last class we have learnt about binomial theorem. So we learnt how to expand binomial theorem various exponents and how to find middle terms and also how to find individual terms by using general term or r plus of the term in the expansion of x plus y whole to the power of n. So in today's class we are going to learn how to find independent term in the expansion of x plus y whole to the power of n. So I am going to start by taking a small example. So now find the independent term or constant term or term do not contain x in the expansion of x plus 1 by x whole to the power of 6. So independent term or constant term do not contain x, all are same. Now how to find independent term in the expansion of x plus 1 by x whole to the power of 6. For finding independent term we have 3 different models. First one is we can find independent term by taking the expansion of x plus 1 by x whole to the power of 6. And second method is we can find independent term by using the general term. And also we can also find independent term by using a shortcut. So today we will learn 3 models. First I am explaining. Right. So what is binomial expansion? So begins with NC0, that means 6C0, and in the first term exponent of x is equal to exponent of the binomial and exponent of y. What is y here? 1 by x. Exponent of y is equals to 0. So in remaining all terms exponent of x consequently decreases and exponent of y consequently increases, and coefficients are the beginning coefficient is 6C0, next one 6C1, x to the power of 5, 1 by x whole to the power of 1 plus 6C2, x to the power of 4, now 1 by x whole square plus 6C3, x cube, 1 by x whole cube plus 6C4, x square 1 by x whole to the power of 4 plus 6C5, x to the power of 1, 1 by x whole to the power of 5 plus 6C6, x to the power of 0, 1 by x whole to the power of 6. So it contains totally 7 terms in this expansion. Now if you simplify it, the value of 6 is 0. The first coefficient is always 1, it is x to the power of 6, and 1 by x whole to the power of 0, that is equals to 1, plus 6c1, the coefficient of second term is always equal to exponent of the binomial, 6c1, that is equal to 6, directly you can write, into x power 5 into 1 by x. So what is 6c2? You know how to find the 6c2. 6c2 is equals to 6 into 6 minus 1 by 2 factorial. So 6 into 5 by 2 into 1. 2 times 3 times. 3 5s are 15. So 15 into x to the power of 4 into 1 by x whole square, 1 by x square. 1 square, 1 by x square. And next one 6c3. 6c3 can be written as 6 into 6 minus 1 into 6 minus 2 by 3 factorial. So 6 into 5 into 4 by 3 into 2 into 1. So 3 2s are 6, 6 cancel. 5 4s are 20. So 20 into x cube into 1 by x whole cube, 1 cube 1 by x cube. 1 by x cube. Now 6c4. 6c4 can be written as 6 into 6 minus 1 into 6 minus 2 into 6 minus 3 by 4 factorial. 4 into 3 into 2 into 1. So 3 2s are 6, 6 cancel. So 6 minus 1, 5, 6 minus 2, 4, 6 minus 3, 4 4 also cancel. 5 3s are 15. 15 into x square into 1 by x whole to the power of 4, 1 to the power of 4, 1 by x to the power of 4 plus 65. It comes as 6 into x into 1 by x power 5. 66 last coefficient is 1, x power 0 1 into 1 by x whole power 6, 1 by x power 6. Now finally small simplification, 1 into x power 6, x power 6 plus 6 into x to the power of 5 by x, x to the power of 5 by x, a to the power of m by a to the power of n, a to the power of m minus n. So it is 1 by x means 1 by x to the power of 1, 5 minus 1 4. So x to the power of 5 by x, that is equals to x to the power of 4. And next one plus 15 into x to the power of 4 by x square 4 minus 2 2 plus 20 x cube by x cube, both are cancelled, 20 into 1 into 1 20 plus 15 into x square by x to the power of 4. So here a to the power of m by a to the power of n, we have one more form, that is 1 by a to the power of n minus m, where m is less than n. Here m is equal to 2, n is equal to 4, m is less than n, so you can use 1 by a to the power of n minus m. So 4 minus 2 2, so 1 by x square, to 1 by x square plus 6 into x by x to the power of 5, 1 by x to the power of 4 plus 1 into 1 into 1, 1 by x to the power of 6. Now see here, independent term or constant term do not contain x. A term which do not contain any variable, identify now. Which term is independent term? So the fourth term is independent term. In the fourth term, this term do not contain any variable. So fourth term is the independent term. Fourth term is the independent term. Therefore, independent term is, so like this we can find independent term or constant term, but term do not contain x by taking binomial expansion. So it takes so much of time in the examination, because you have to write the full binomial expansion. Here exponent is 6, no problem. Suppose exponent is 11 is given, so it takes so much of time. So is there any different model? General term or r plus 1 is second method by using r plus 1 term. First compare 1 plus y, x plus 1 by x whole to the power of 6 with x plus y whole to the power of n. So here x is equals to x, y is equals to 1 by x, and n is equals to 6. Now what is r plus 1 term or general term in the expansion of x plus y whole to the power of n? So NCR, x to the power of n minus r, y to the power of r. Here n value is 6. Do you know r value? We don't know r value, so leave it, write as it is. Into, so what is x? X is equals to x to the power of n minus r, 6 minus r, into what is y? Y is equals to 1 by x whole to the power of r. So that is equals 6 cr, x to the power of 6 minus r. Now what is the value of 1 by x whole to the power of r? It can be written as 1 to the power of r by x to the power of r, according to a by b whole to the power of m, a to the power of m by b to the power of m, where b is not equals to 0. So that is equal to 6 cr, x to the power of 6 minus r, 1 to the power of r, again 1 by x to the power of r. Again you can also simplify here, it is numerator x to the power of 6 minus r, and the denominator x to the power of r is there. Now it can be written as 6 cr into x to the power of 6 minus r by x to the power of r. Now it is in the form of a to the power of m by a to the power of n, a to the power of m minus n. So that is equal to 6 cr, x to the power of m minus n, m 6 minus r minus n r. So 6 cr, x to the power of 6 minus r minus 2r. Okay, so the entire process is simplified. It is a simplified form. Now our required value is independent term or constant term or term do not contain x. Term do not contain x means we have to remove this variable term. How do you remove this variable term? By taking its value is 1. If you take its value is equals to 1, then 6 CR into 1, we get 6 CR. We get only constant. This is the constant term or independent term or term do not contain x. For that, you have to take x to the power of 6 minus 2r is equals to 1. So therefore, to get an independent term, this x to the power of 6 minus 2r, that is equals to 1. So here LHS, in the LHS, the base is x. Now this 1 can be written as x to the power of 0. So as the bases are equal, you can equate exponents. 6 minus 2r is equals to 0. Then minus 2r is equal to minus 6. 2r is equals to 6. R is equal to 6 by 2. That is equals to 3. Now R value is 3. You got R value. Now according to general term, T R plus 1 is equal to NCR x to the power of n minus r y to the power of r. You got R value. What is R value? 3. Now replace here 3. 3 plus 1 how much? 4. So fourth term is the independent term. If R is equal to 3, then fourth term is the independent term. If any problem, if you get R is equal to 4, the independent term is fifth term. R is equal to 5, sixth term is the independent term. Now the independent term is, now this R is equal to 3, substitute here. Already this value we have taken as 1, so therefore the required constant term is 6CR. What is R value? 3. Therefore independent term is equals to 6CR. No need to take x to the power of 6 minus r because we have taken it as equal to 1. So 6C, R value is 3. Now what is 6C3? 6 into 6 minus 1 into 6 minus 2 by 3 factorial. So 6 into 5 into 4 by 3 into 2 into 1. 3 2s are 6, 6 to cancel. So 5 4s are 20. So 20 is the independent term in the expansion of x plus 1 by x whole to the power of 6. So like this you can find independent term or constant term or the term do not contain x by using general term in the expansion of x plus y whole to the power of n. Now I am going to introduce a shortcut to find independent term or constant term or term do not contain x. So this shortcut is very useful in the competitive examinations. Right. Now what is the shortcut? So before using shortcut, first express the given binomial in the form of a into x to the power of p plus b by x to the power of q whole to the power of n. Express the given binomial in the form of a into x to the power of p plus b by x to the power of q whole to the power of n. Now compare the given binomial with a into x to the power of p plus b by x to the power of q. Here we need some values. Those values are p, q and n. So in this given problem, a into x to the power of p can be written as 1 into x to the power of 1. Now what is p value? P is equals to 1. b by x to the power of q, 1 by x, it can be written as x to the power of 1. Again q is also 1. What is n value? N is equals to 6. Now you can find directly by using a shortcut. R is equals to np by p plus q. R is equal to np by p plus q. So what is n value? 6 into p value 1 by p plus q, 1 plus 1. So 6 by 2, that is equal to 3. Now what is R value? 3. If R value is 3, then which term is independent term? Therefore fourth term is the independent term. Which term is independent? If they ask if which term is independent, directly you can write the fourth term is the independent term. Fourth term is the independent term. Now what is that independent term? Now use the formula TR plus 1 is equals to NCR x to the power of n minus r y to the power of r. So T, R value is 3. 3 plus 1, 4. NCR, n value 6. 6C, R value 3. X, n minus r, 6 minus 3. Y, 1 by x whole to the power of 3. So 6C3 into x cube into 1 cube by x cube, 1 by x cube. So 6C3. What is 63? 20. So like this, you can find directly without doing that much of long process. If you use this shortcut, you can save your time in the competitive examinations. But if take a small precaution, that is, before applying this shortcut, first you should express the given binomial in the form of a into x to the power of p plus b by x to the power of q whole to the power of n. After that, select the values of p, q and n. In this example, p is equal to 1, q is equals to 1 and r is n is equals to 6. So our target is to find the value of r. So r is equals to np by p plus q. So if you replace these all values, r is equal to 3. R is equal to 3 means the fourth term is the independent term. So now what is the independent term? These values replace a general term. So tr plus 1 is equal to ncr x to the power of n minus r y to the power of r. If you replace all these values, then you get the independent term. Now see one more example for finding independent term by using shortcut. So first check the given binomial is in the form of ax to the power of p plus b by x to the power of q whole to the power of n. Yes, the given binomial is of the form a into x to the power of p plus b by x to the power of q whole to the power of n. What is the value of p? P is equals to 2. Q 2. What is n value? 8. Now we have to find the value of r. Now how do you find r value? By using r is equals to np by p plus p. What is n value? 8. P value 2 by p plus q 2 plus 2. 16 by 4, that is equals to 4. R is equal to 4. That means therefore fifth term is the independent term. Fifth term is the independent term. Fifth term is the independent term. Now how do you find this fifth term? By using general term. Tr plus 1 is equals to ncr x to the power of n minus r y to the power of r. So t, r value is 4. T 4 plus 1. N value 8. 8c, r value 4. X, what is x? 6x square. N minus r, 8 minus 4. What is y? Minus 5 by x square. Y is equals to minus 5 by x square. X 6x square. Y value minus 5 by x square. Now replace here. Minus 5 by x square whole to the power of r value is 4. So 8c4 into 6x square whole to the power of 8 minus 4, 4 into minus 5 by, so this minus 5 by x square can be written as minus 5 to the power of 4 by x square whole to the power of 4. So 8c4, 6x square whole to the power of 4, ab whole to the power of m, a to the power of m into b to the power of m, 6 to the power of 4 into x square whole to the power of 4 into minus 5 whole to the power of 4 by x square whole to the power of 4. So x square whole to the power of 4, x square whole to the power of 4, x to the power of 8, both are cancelled. So remaining value 8c4 into 6 to the power of 4 into 5 to the power of 4. So why are writing 5 to the power of 4? Minus to the power of even number becomes minus becomes as plus. So the remaining value is 8c4, 6 to the power of 4 and 5 to the power of 4. So this value gives independent term in the expansion of 6x square minus 5 by x square whole to the power of a. So like this you can find independent term or constant term or term do not contain x in the expansion of in any binomial expansion by using the shortcut r is equal to np by p plus q. R gives which term is the independent term. After that you can use general term by finding the independent term. So let's now see one more example. Find the coefficient of x cube in the expansion of 3x plus 4 whole to the power of 8. In previous example, we found term do not contain x, but in this problem, we are going to find coefficient of x cube. Coefficient of x cube. So here also you can use three models, using a binomial expansion and also using the general term and also you can use the shortcut. Now I am using shortcut to find the coefficient of x cube. So before that, whenever you want to find coefficient of x to the power of k in the expansion of ax to the power of p plus b by x to the power of q whole to the power of n, the r value is np minus k by p plus q. One subtle difference between the previous problem, previous problem is to get independent term, there k is equals to 0 because there is no variable, that means k value is 0. That is why we have taken k is equal to 0. This problem is not independent term, you have to find coefficient of x to the power of k. So the r value is np minus k by p plus q. So before that, express the given binomial in the form of ax to the power of p plus b by x to the power of q whole to the power of n. Actually, in this problem, it is 3x plus 4. It is not in the form of a into x to the power of p plus b by x to the power of q. Okay. So first I am modifying this 3x plus 4 whole to the power of 8 can be written as 3 into x can be written as x to the power of 1 plus b is there 4, but x to the power of q is not there. This 4 can be written as 4 by 1. Now 1 can be written as x to the power of 0 whole to the power of 8. So 3 into x to the power of 1 plus this 4 can be written as 4 by 1. 4 by 1 can be written as x to the power of 0 whole to the power of 8. Now this is in the form of a into x to the power of p plus b by x to the power of q. What is p value? P is equals to 1. Now p is equals to 1. What is q value? Q is equals to 0. What is n value? N is equals to 8. What is k value? We have to find coefficient of x power k here. Now we have to find coefficient of x cube. What is k value? 3. Now these are values substituted. R is equals to np minus k by p plus q. So n 8 into 1 minus k value 3 by p plus q 1 plus 0. So 8 minus 3 by 1. So 8 minus 3 5 by 1, that is equals to 5. R is equal to 5 means in the sixth term we get coefficient of x cube. In the sixth term we get the coefficient of x cube. Therefore, how do you find coefficient of x cube now? By using general term. TR plus 1 is equals to NCR x to the power of n minus r y to the power of r. So T 5 plus 1, r is equal to 5. That is equal to T6, that is equals to NCR 8C 5 x. What is x? 3x whole to the power of n minus r 8 minus 5. Y 4 to the power of r value is 5. So that is equal to 8C5 into 3x 8 minus 5 3 into 4 to the power of 5. So 8C5 3x whole cube can be written as 3 cube into x cube into 4 to the power of 5. Therefore 8C5, separate all constants. 8C5 into 3 cube 27 into, no need to write, directly write as 3 cube into 4 to the power of 5 into x cube. Now tell me what is the coefficient of x cube? Therefore coefficient of x cube is equals to 8C5 3 cube into 4 to the power of 5. So like this you can find independent term and also coefficient of x cube or coefficient of x power 5 in binomial expansion by taking this shortcut. So if you want to find coefficient of x power k, what do you take? R is equal to np minus k by p plus q. If you want to find independent term, what is R? np by p plus q. After finding R, you have to substitute all the values in the general term or R plus 1 term in the binomial. Now we are going to learn some more shortcuts. The first one is the greatest. What is the greatest binomial coefficient in the expansion of x plus y whole to the power of 8? what is the greatest binomial coefficient in the expansion of x plus y whole to the power of 8? What are the coefficients of the terms in the expansion of x plus y whole to the power of 8? Actually the coefficients are 8c0, 8c1, 8c2, 8c3, 8c4, 8c5, 8c6, 8c7, 8c8. These are the coefficients. What we get? We get these coefficients in the binomial coefficients of the terms in the binomial expansion x plus y whole to the power of 8. Among all these three, what is the greatest value? So how do you find them? You can find the value of each coefficient, 8c01, 8c18, like that. After finding these all values, you can decide the greatest binomial coefficient. So it takes so much of time. Is there any shortcut to find the greatest binomial coefficient? Yes, there is a simple shortcut to find the greatest binomial coefficient in the expansion of x plus y whole to the power of 8. Binomial coefficient, the greatest binomial coefficient in the expansion of x plus y whole to the power of n is nc n by 2. nc n by 2. When do you use this shortcut? This shortcut is applicable when n is even. If n is even. If the exponent is even, then the greatest binomial coefficient is nc n by 2. If n is odd, if the exponent is odd, then what is the greatest binomial coefficient? Is nc n minus 1 by 2. You can use either nc n minus 1 by 2 or nc n plus 1 by 2. Okay? So the greatest binomial coefficient in the expansion of x plus y whole to the power of n, if n is even, then you can use the shortcut nc n by 2. The greatest binomial coefficient in the expansion of x plus y whole to the power of n, if n is odd, you can use either nc n minus 1 by 2 or nc n plus 1 whole by 2. Now apply these shortcuts for finding the greatest binomial coefficient of the given example. Here once observe exponent. What is the exponent here? 8. n is equal to 8. 8 is an even number. So the greatest binomial quotient is nc n by 2. That means 8c 8 by 2. That is equal to 8c 4. So what is 8c 4? 8 into 8 minus 1 into 8 minus 2 into 8 minus 3 by 4 factorial. So 8 into 7 into 6 into 5 by 4 into 3 into 2 into 1. Do cancellation. 4 table 2 times. 3 2s are 6, 6 cancel. So 2 5s are 10, 10 into 7, 7. So what is the greatest binomial coefficient? 70. Now suppose here 9 is given. Now which formula do we select? We select clearly either nc n minus 1 whole by 2 or nc n plus 1 whole by 2. nc n plus 1 by 2. Because here 9 is a odd number. Okay children, this is another shortcut to find the greatest binomial coefficient. The students ask a small doubt children, that is how to find the value of 0 factorial. I already explained what is n factorial. The product of first n natural numbers is denoted by n factorial. The product of first n natural numbers is denoted by n factorial. So 1 factorial is equal to 1, 2 factorial is equal to 1 into 2, that is equal to 2, 3 factorial, 1 into 2 into 3, that is equal to 6. Like this you can find the values of factorials. Now one student asked, sir, what is the value of 0 factorial? Now how do you find it? So this value is derived from the formula of NCR. NCR is equals to n factorial by n minus r factorial into r factorial. So in this formula, if we take n is equals to r, let n is equals to r, then it changes as nc n is equal to r. I am replacing r is equal to n or n is equal to r, no problem. nc n is equals to n factorial by n minus r is equal to n factorial into n factorial. Here I have replaced r is equals to n. So what is the value of NCL? The value of NCL, it is the last coefficient of last term. NCL is equal to 1. 1 is equals to n factorial by, so one see here n factorial one time here, one time cancel here, 1 by n minus n, 0 factorial. Now if you do cross multiplication, 0 factorial into 1, so 0 factorial, that is equals to 1. So like this you can find the value of 0 factorial by using NCR is equals to n factorial by n minus r factorial into r factorial. Okay children, what is the value of 0 factorial? The value of 0 factorial is 1. And next one more doubt, sir, is it NCR is equals to NC n minus r? NC n minus r. This is the second one. So both values are same. NCR is equal to NC n minus r. Now we can prove it. So you know the formula of NCR, that is equals to n factorial by n minus r factorial into r factorial. It is LHS. Now take the RHS. RHS is NC n minus r. Now these values substitute in this formula. Here n is equal to n, r is equal to n minus r. So in the formula n factorial by n minus, what is r? N minus r. So n minus of n minus r factorial into r factorial. What is r factorial here? N minus r factorial. So n factorial by n minus into n minus n, minus of minus plus r factorial into n minus r factorial. N minus n 0, so n factorial by, so the remaining values are r factorial into n minus r factorial. See children, once NCR is equals to n factorial by n minus r factorial into r factorial, NC n minus r also n factorial by n minus r factorial into r factorial. So finally we conclude that NCR is equals to NC n minus r. For example, the value of 5C2 is also equals to 5C 5 minus 2, that is equal to 5C3. If you compare 5C2 with NCR, n is equals to 5, r is equals to 3. It is equal to NC n minus r, that means 5C 5 minus 2. So 5C2 is also equals to 5C3. 10C2 is also equals to 10C 10 minus 2, 10C8. 15C3 is also equals to 15C 15 minus 3, 15C12. Okay children? Okay children? So this is about entire binomial theorem. In this chapter we learned how to expand a binomial with various integral powers, and also we found terms and also independent term, and how to use shortcut to find independent term, and also how to find coefficient of x power k in the binomial expansion, and also we learned some important shortcuts also. Still, if you have any doubt, you can send through WhatsApp. Again, I will clarify your doubts. Thank you.
నేను మాత్రం మా ఇద్దరు పిల్లల్ని క్వాలిటీ ఎడ్యుకేషన్ అందించే ఉల్లంపర్రు మాంటిసోరి స్కూల్లో మాత్రమే చదివిస్తాను. ఇలా అన్నీ ఉన్న చోట మన పిల్లల్ని చదివిస్తేనే వాళ్ళకి మంచి భవిష్యత్తు ఉంటుంది.
నాకు అన్ని నెంబర్ 1 కావాలి. అందుకే నా పెద్ద మనవరాల్ని అన్ని వసతులతో క్వాలిటీ ఎడ్యుకేషన్ అందిస్తున్న స్కూల్లోనే జాయిన్ చేశాను.
ఏ స్కూల్ సార్ అది?
Ullamparru Montessori School. Quality education lo number 1. Cultural activities lo number 1. Sports lo number 1. Campus lo number 1.
అది
మీ పిల్లల బంగారు భవిష్యత్తుకు మాది బాధ్యత.